Refrigerant regulations are evolving rapidly, and for plant engineers, 2026 marks a pivotal year. The American Innovation and Manufacturing Act, or AIM Act, and the Environmental Protection Agency's Technology Transitions Rule have set a global warming potential, or GWP limit of 700 for new industrial process chillers operating above minus 22 degrees Fahrenheit, effective January 1st, 2026. However, the Environmental Protection Agency announced a reconsideration in October 2025, proposing delays for semiconductor chillers and adjusting thresholds for other sectors. Despite this, at least 12 states, including California, New York, and Colorado, have enacted their own low GWP requirements. California's Air Resources Board, or CARB regulations, have been in effect since 2024 for certain chiller categories. As one industry product manager put it, the ship has sailed on high GWP refrigerants. The bottom line, the next chiller you buy should use a low GWP refrigerant, not just for compliance, but to avoid investing in soon-to-be obsolete equipment. The transition to low GWP refrigerants brings up the A2L flammability question. Most new refrigerants replacing R410A and R134A, such as R454B, R454C, and R513A, are classified by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE, as A2L, low toxicity, low flammability. A2L refrigerants have a very low burning velocity, require a high energy ignition source, and need a high concentration in air to ignite. Industry testing shows A2L refrigerants need about 1,000 times more ignition energy than A3 class refrigerants like propane. While the physics are reassuring, code and safety requirements vary by location, especially for indoor installations. For those wanting to avoid flammability concerns entirely, carbon dioxide, or CO2, offers a non-flammable, non-toxic alternative, though it requires higher operating pressures. Engineers are right to ask about performance trade-offs. The difference between R410A and its A2L replacement, R454B, is less than 5%, typically a slight loss on the compressor side and a slight gain on the condensing side. For most industrial cooling applications, this is negligible. However, early A2L-compatible equipment has been 15 to 40% more expensive due to added safety components and limited production. As manufacturing scales, these premiums are expected to decrease. Many new low GWP chillers also feature inverter-driven compressors and pumps, delivering energy savings under part load conditions that can offset minor capacity reductions. There are no true drop-in refrigerant replacements for legacy systems. Different thermodynamic properties mean new chillers must be purchased, as existing units cannot be safely retrofitted. However, manufacturers like SMC have designed new low GWP chillers to match the external dimensions, port sizes, and performance envelopes of their legacy units. This means the new chiller can drop in mechanically, simplifying the transition. SMC's comprehensive low GWP chiller family addresses a wide range of industrial cooling needs. For general-purpose cooling, the HRSF series uses R454C, while the HRSC series uses CO2 for the lowest GWP. Both offer precise temperature stability and multi-alarm monitoring. For large capacities, the HRSC 090 and HRSC 100 use CO2, and the HRSF and HRSHF series use R454C and R32, respectively, with inverter control for energy savings. The HRRF rack-mounted chiller fits standard 19-inch racks, and semi-certified models like the HRZF0110 and HRZC serve semiconductor applications, with CO2 options providing plus 0.02 degrees Celsius stability and air freight eligibility. The HRLF dual-channel chiller supports laser processing with copper-free construction and advanced communication options. All models are designed for straightforward mechanical replacement of legacy SMC units. SMC's approach gives engineers flexibility. Choose R454C if your facility is comfortable with A2L refrigerants and wants minimal redesign. Opt for CO2 if you require non-flammable, ultra-low GWP refrigerants, especially for semiconductor or air freight applications. R32 is ideal for large-capacity cooling, where a GWP under 700 meets your needs and broad service support is important. Audit your current chillers, check state and local codes, review flammability policies, and specify low GWP units for future purchases. The technology is mature, products are available, and price premiums are shrinking. The low GWP transition is here. Make your next chiller investment a future-proof one.